Good morning, everyone. All right, we might have a little bit of a smaller crowd this week since a lot of folks are out at the OpenStack conference. So we'll give another minute here for people to join and then get started. All right, let's get this show on the road. We've got a couple of new pull requests this week. There's one for enabling BlueFS sync writes. It looks like that might actually be a little bit faster than leaving them disabled, at least for small I/O. Primarily for hard drives, we saw it improving things a little bit. For large writes, it might actually be a little bit slower. It appears so far that the improvement for small writes is bigger than the hit we take on large writes. So I think we're probably going to do it. We've got a couple of last minute tests to run through there with RB cache disabled. Since the test that we had, we accidentally forgot to disable that when we were running through them earlier, but I suspect that we'll probably see the same thing. So I imagine that will probably merge this week. There's another PR here for the manager to optimize daemon state index cull. I haven't looked too closely at that, but it looks like we were like going through the entire daemon list, and we probably don't need to do that. So not much response on that yet, but I think it probably makes sense. There was a number of things here that closed. Let's see. There was a scrubbing one that I didn't look at all, so don't know much about that one. It merged pretty fast though, so Sage must have felt like it was pretty clearly a win. The CRC cache miss perf counter one from Piotr. That was interesting. I think the cache miss rates were a lot higher than Sage suspected, and it was not entirely clear why that was. So it looks like it did merge, so that's good. I wouldn't mind hearing more from Piotr if he's around on that one. Let's see. Oh, you are here.
Yeah, I am. Oh.
Anything interesting going on with that? I know it was you were seeing, at least to me, with some interesting numbers.
You know, I actually haven't had time to do any more testing on this, but since this is now merged, you can test it for yourself, or anyone else can just check how does it work for them, for their workloads like RBD, Ceph FS, and other stuff. Because I believe it's dependent on the workload.
Sure. Yeah, it makes sense. Cool. All right. Next on our list, compaction read ahead for BlueStore RoxyB. This was a really small change. All it was enabling a compaction read ahead option that RoxyB introduced in 2015. But the gist of it is that for a while we've been seeing really heavy read workload during small random writes with BlueStore, and we didn't really totally know why. when we looked at wall clock traces, it turns out that RocksDB makes a random read call, which was confusing, just because we thought that it'd be able to sequentially read through the SST files. And in fact, that's what it does. It's a random read call that acts sequentially. So the end result of it is, by default, RocksDB was not doing any kind of read ahead for any of that. It was just doing tons and tons and tons of mostly sequential but overlapping reads. And by enabling read ahead specifically for compaction, we were able to turn those into much larger reads, and it reduced the time that we spent in the compaction thread from spending something like 70% of the time in that thread doing reads to down to like 15% or something. So it was a really huge win for a very small code change. So that's really good. I expect for people that are doing BlueStore testing, they will see a pretty big difference in any kind of traces that they do and CPU utilization because of that. We had already actually reduced BlueStore CPU usage pretty dramatically maybe a month or two ago, but this kind of helps out even more. So that's very good. There's another PR here by Piotr to use the new to basically, there's a couple places where apparently we weren't using the new encoding, and this fixes that. So that's good. And then there was also a BlueFS sync write option, adding that in, which was kind of the prerequisite to the one up above, the 15.0.3.4 that merged. So that's it for stuff that closed. There's an ongoing discussion regarding the sharded op work queue. There were it's showing up in some wall clock traces that we've been doing. Sage had an idea for changing the locking there that didn't actually result in any kind of improvement. So it's kind of back to the drawing board, figuring out if there's anything we could do there. And Sage actually has a new idea for removing certain locking entirely, I believe. So hopefully he'll be able to prototype that and we can test it out. There's this tag fast dispatch messages with min epoch. I have to confess I haven't looked at that at all, so I don't know anything about it. And then there's a lot of ongoing discussion right now regarding this improved CRC calculation for zero buffers. I think Piotr's been commenting a lot on that. It sounds like there's kind of a crossover point where the existing method might be better for small sizes, while this new method is bigger for large sizes. So I think the thought right now is to figure out where those are and when we should use the new thing that Adam's been working on. But that was just me skimming over the PR. So let's see, no movement. There's still this kind of idea out there about putting BlueFS in the middle of the shared device. Maybe it will help. Again, this is the thing though, where that only I think makes sense if we are filling the device up fully with data. And the idea is to reduce the amount of distance that the head has to seek. But if we're not filling up the device, putting data in the middle of the device then means that we're actually kind of towards the end of where data is laid out. So I'm still not convinced that this actually makes sense. In the testing that we did, there's almost no difference, to be honest. So probably we're still at the point where other stuff matters more than this does, but who knows? We'll see. Maybe it does make sense if we assume that people have pretty full disks. We have this one from Jianpeng about combine the callback op committed, op applied. It sounds like I think people think this is generally a good idea, but right now I guess it's buggy. There's still the adaptive throttle work that's kind of sitting out there. What else? Still this kind of big one about separating the KV sync thread into two parts. Igor was saying that's a really big win. I still haven't gotten a chance to test it recently, so I need to do that. But it sounds like it's definitely something we need to figure out. it is, I believe, still deadlocking. So we need to understand why that is. And then yeah, we've got a huge amount of other stuff here that we need to go through. A lot of Blue Store stuff, and then I think some async messenger things for RDMA are still out there, but really a lot of it's Blue Store. So yeah, I think I'll leave it at that. That's probably enough to go through for this week for pull requests. I've added a couple of things in here, but I believe there were a couple of folks that wanted to talk about their own work this week. So I'm going to open the floor now. Does anyone have anything that they would like to present or talk about this week before I talk about some of these other things?
Hey, Mark. This is
Yes.
from Alibaba.
Yes.
Yeah, as we talk with you, we're going to present one of the items we're working on today.
Okay, perfect.
Take
it away.
We already submitted a pull request, but in the meantime, we want to share the idea, and we want to looking forward advice or comment from the whole community to improve this pull request. But today we're going to share with the community of the idea first, and also we have the performance data to share. And in the meantime, if any of us can give us the comments, that would be great. Okay, so we're going to share the screen. Share the screen. Can you guys see the screen?
Yes.
Okay, I'm going to open the presentation. So basically today I'm going to introduce the basic idea first. Then several engineers from Alibaba going to show the performance data and how we design. Of course, we in the end going looking for your guys' advice. So today there's two engineers will join. Probably several engineers from Alibaba already joined the meeting, but two of the engineers going to present the data with me. First one is Jesse, and second one is Yanjiang. They are working on these issues. And as I said, of the background, why we so care about the performance, because Alibaba, most of the time, we run the high performance application on top of the Ceph. And that's the reason why we find a lot of place try to increase the performance. But of course, sometimes we break there's some rules, like strong, consistent rules. But there, as I said again, we need looking for your guys' advice, how we're going to improve. But in the end, our ultimate goal is try to bring the Ceph to their next level for high performance applications. That's pretty much the goal. I just want to say it again. So in terms of high performance, we actually today bring the database team in Alibaba to work with us, see how we're going to improve the Ceph performance for a gigantic database applications in Alibaba and AliCloud. And I just give the basic ideas, and if everybody have interest, probably everybody can go to this pull request. But of course, this pull request right now was reviewed by Greg and unfortunately closed. But we want to present it today and want to share what we think. In the meantime, we look for you guys' advice as well. So basically, we want to, when we send 3 requests for replicate, and we want to get two reply, and then we think this reply consider as this write complete. So basically, they're going to address their no OSD issues. So I'm going to move that our engineer Jesse going to or Yanjiang going to present the next slides. Yanjiang, are you here?
Okay, now I'm Jesse from Alibaba Database Group. Yeah, and as James said, that we have a project to split the storage layer from the relational database. So we much care about the average latency, especially for the 4.9 latency. So we do the commit majority feature to improve the latency for our business. We have two stages. So first stage, we did the commit majority at the server side. Of course, and as James said, we at this business circumstances, we may lost some the data consistency. So we focus much more on the latency. So we did the commit majority, and at the stage 2, we may did the commit majority at the client side as a rough protocol. So today, and this slide, we just finished the commit majority feature at the client side. So at the August, and we will start another project to finish the feature commit majority at the client side, because it will change much more code. So it's hard, and because of the time and the project. So today, and we share some data for the commit majority we have done. This is yeah, James.
So Jesse, can you see their slides?
Okay.
Can you see the slides? Can you see the slides?
Yeah, I can see.
Okay, go ahead.
Okay. Here is a test environment. So we have 3 servers and 24 OSDs with 10.2.5 versions, and with upload image 100 gigabyte. So we're using the FIO to test the performance. We test the case under the 400 seconds. So next slide, please. This is average latency. It has been improved. So for the average latency, it has 10%. So this is IOPS that we have tested for the commit majority. So next slide, James.
So the IOPS, generally speaking, was improved for more than 10 to 15.
Yeah. So next slide.
Do you see it? I just went to the next page. The latency, right?
Yeah.
So this is the latency slide. So latency was also getting improved or not. And with the enabled, we have very stable average latency instead of very spiky latency. And in average, we know down the latency for more than 10 to 15% as well, comparing to the IOPS. IOPS got improved more than 10 to 15.
Yeah, this is the test data for commit majority. Using the FIO we have tested.
Yeah, so here is a very important message we're going to send out. And as everybody know, we actually apply Ceph into high performance OLTP database. The database care a lot about the tail latency. So here we especially pay a lot of attention to 4.9 tail latency. You can see from the data we can know down their 4.9 latency to 4 times, almost 3 or 4 times. That's a huge impact to our application, because we use e-commerce or database or OLTP database. We have a very stringent worse rigid requirement towards the tail latency. Because any of the tail latency or spike can break any of the transaction happening in the e-commerce. So there's no way for us to tolerate any of the spike. So that's the reason why we try every means or every method to low down the tail latency. This pull request actually help us to achieve this goal to low down the tail latency 3 times almost. And of course the IOPS get improved almost 13%. Okay, I just want to add on. Jesse, you can keep going.
Okay, we have did the community majority at the server side. So in the future, we may implement the community majority at the client side, just using the Raft protocol. So it may be much more difficult. So today we implemented it at the server side. So I know that if any guys can have any comments at that, and also we may not cover any corner case. So if it is any risk for this feature, so it will be welcome for that, and we will appreciate.
Yeah. So Mark, is Greg over here?
Greg is at OpenStack. So yeah, I was actually thinking the exact same thing because of his comment on the pull request here. It'd be really good if he was here, but yeah, I don't think he's probably on a plane or something right now. I do want to say that this is really a good showcase of kind of what we lose right now in terms of tail latency, kind of by our current scheme, right? I mean, your code is showcasing that we've got a lot of ground to make up to improve tail latency, and that this is a good direction in terms of investigation and work. That probably just like you guys, I'm pretty concerned about Greg's comment that if a certain OSD can't be used as an authoritative source for data, kind of by the way that this PR is implemented, if it's not safe to do that, potentially it makes kind of our entire recovery scheme not safe. So I'm not familiar enough with how our recovery works to be able to really give you any guidance on that. But certainly Greg and Josh, when they're back, I think you'll want to work very closely with them to see if there's kind of a way to get around this.
Yeah, I totally appreciate it for Mark your comments, because internally we do lots of review and design, and we try to make sure we cover all the current case, because recovery is a big issue, and we know the strong consistency model as well. And when we design the code, we think we at least try to come out several testing case and cover the corner case. And in the meantime, we already run lots of testing experiment in our data in the cluster. Here we only show you like a 3 server 24 OSD cluster. Actually, we run like a 200 or 300 OSD already in our applications. So we just want to have a chance to talk with Greg and share what we already found, what we think regarding to these questions, and how we're going to approach this problem, and how we avoid what he mentioned in their comments. Because of course, I totally understand what Greg comment, because data integrity never can be compromised. For sure, to Alibaba, of course, we cannot compromise. We cannot tolerate any data loss. That's for 100% for sure. But at least we want to have a chance to talk with him directly and say, hey, what do we think? How we design like this way? How are we going to avoid, to compromise the data persistency or data consistency? And of course, we strongly looking for their comments as well. So we just need to have a chance. Please bring this word to Greg, and we have either phone call or email. That would be fine to all of us.
Absolutely. Yeah, I'll see if I can. I'll reach out to him and see if we can get something like that set up. And then my guess is that the process here will be making sure that it passes a review, just by Greg or Josh or Sage or somebody that is familiar enough with the recovery code to be able to be authoritative on it. And then the other big thing will be making sure that it passes a Rados thrashing suit in our Truthology suite.
Yes.
Because that's kind of what we use to really try to exercise code like this. So I don't know. Have you run through Truthology at all at Alibaba?
Yeah. Far, yeah. Go ahead, Jesse.
Yeah. We have improved the Truthology, and we did a lot of work for the Truthology, especially for the disaster simulation. Like OST fault, hardware fault, and the network fault. So we did a lot of implementation work for this disaster fault or the other fault, hardware fault. So so for the Alibaba, and we using the database using the Ceph as its storage. So we very the stability and SLA, I mean the service level agreement, is very important for us. So that's why we did a lot of work for Truthology to test our distribution storage. Here we're using the Ceph, so it's really important for us. We designed several keys to test the commit majority, and currently, and it is working very, very well.
Excellent. Yeah, that, I mean, passing.
So Mark, I just want to make a clear statement over here about their data integrity. We cannot afford any data nodes. This is number one. Number two, we have our in-house Truthology, and we added way more tests than current technology to test the integrated stability and performance. We have we do our lots of their hardware failure injection and networking failure injection, and also the storage failure injection, CPU failure injection, and also we have lots of combined testing case was developed. We later on going to consider open source it, but so far in current stage we still in development. So we have a very strong testing suite in-house of Alibaba. I just mentioned this one. But later on we can slowly open source what we already did to the source.
Yeah. And next week, another guy will share how the work we have been done for the Truthology.
So that'd be fantastic.
Yeah. So we basically want to collaborate with the Ceph community to improve how, especially right now we focus on high performance. We do lots of work on high performance. So for example, next week we also going to present another improvement we made towards their PG and their whole object store. We're going to submit a PR, and we're going to talk next week. So we have
Yeah. Fantastic. Yeah, I think both being able to show that that you're passing the Rados thrashing suite will be important. I think that's key for this to be able to be merged. But then also any other work that you've added, any additional suites for Truthology or any additional tests that you've added, I imagine that folks will be really interested in that, especially if it's picking up anything that is not currently being caught by our Rados suite. I know we actually just recently got hit with a blue store bug that was being detected in the RBD suite that should have been picked up in the Rados suite. So having more people adding more tests there, I think would be really good.
Yeah, we have an in-house testing engineer development team over there dedicated on developing testing case for Truthology in Alibaba.
Cool, very cool. There was a comment in the chat here about your slides from last week. And I think folks are wondering, is it possible for you guys to post those up on the Ceph Develop mailing list or post them somewhere else?
I thought I already sent out. I make an attachment to an email and send out already. You got Bruce, do you receive it? You don't receive it?
I think it didn't make it to the mailing list itself. I think you have mailed just particular persons.
No. Oh, okay. I will check my email again. I make sure going to send out today. And is there any limitation to the attachment? Because I make the. Oh, it wasn't attached. Okay. Probably I check my email. It was already attached, but probably was filtered by the email system.
I think it was deleted by the mailing list server.
Okay.
Yeah, I've noticed recently that when I have big traces that I try to attach to emails going to Ceph that sometimes it totally silently drops the email. So yeah,
Okay.
it's possible that you might have to upload it to like Dropbox or something else somewhere, and just provide the link in the email.
I'm going to do it today. Okay. In the meantime, we're also going to share these slides as well to the community.
Very good. Very good.
And
Mike,
in the meantime, Mark, if possible, can you help us to make connection between us, the Alibaba team, and Greg and Josh to work together on this PR?
yeah, absolutely. And I know Greg wanted to, or sorry, that Josh wanted to talk to you about your async recovery work as well from last week.
Okay.
So I think it'd be good to maybe have maybe we can talk about a couple of these different things that you guys are working on, and kind of just get everybody on the same page and kind of an idea of where to go from here.
Okay, that would be great if you can make us a connection. We also want to talk with Josh and Greg as well.
Cool. Yeah, I'll see if I can set something up with them.
Cool. Thank you.
All right. Any other questions for Alibaba guys?
Jesse, do you have any other questions?
Currently, it's very good. So we, if we have any comment or any comment for that, and we will appreciate. And we from Alibaba database group, and we still and do some work for the Ceph, and also we in the future we focus on the tail latency or also performance and the high throughput. So we will focus on these features for Ceph. So it's very important for us. And for Alibaba database side, we are just doing the project. We have already mentioned that we're splitting the storage layer from the relational database. So we will focus much more on the stability and the performance. So I think, and in the future, we will work with Ceph community, and it's very good for us. So in the future. So thanks.
Very good. Yeah, I think we all look forward to seeing more testing and more code from you guys. So thank you very much.
Thank you.
Thank you.
All right. Let's see. Does anyone else have anything that they would like to talk about this week? One thing in the chat.
Hi, Mark. Just a quick question.
Yes. Hey, Nick.
So I've been offline a couple of weeks doing other things. What was the result of the deferred write? Did the performance become near file store in the end, or is that still sort of ongoing? So I know Sage merged some extra bits and pieces in.
Yeah, I believe the PR is actually still stuck due to test failures. Let's see. Oh, no. Rewrite deferred right handling. That did merge. So I'm trying to remember exactly what happened with that. I don't think that we actually got to the point where we were quite as fast as file store, but to be honest with you, it's been a while since I looked at it, so I don't remember off the top of my head as well. If I remember right, though, we did make it significantly better than it was.
Yeah.
Master mashups. Yeah, unfortunately, Nick, I don't remember exactly. I've run through so many tests in the last couple of weeks. I don't remember exactly what we were seeing when we did that. So I'll have to get back to you on it. But yeah, no, for some reason I didn't even think it had merged yet, but it looks like it did. So yeah, I'll let you know.
Okay, that's brilliant. Thank you.
And Nick, you'll be pleased to know too that other people have been starting to pick up on the C state latency improvements by forcing C0.
Yeah, no, that's yeah, I've seen that. That's really good.
Yeah.
It's still not ideal. I'd love it if the kernel was a bit more intelligent around the whole thing, but I guess for now, at least that's getting some traction.
Yeah. It looks like even there's some discussion about whether or not that should be kind of the default setup, at least until the kernel is, as you said, better about figuring out C-state transitions. So yeah, we'll see what happens. But yeah, it's more people are starting to notice this as well. So yeah, we'll find out.
Excellent. Cool.
Yeah. All right. Well, I guess I will jump in here then and talk a little bit more about what we've been doing for the last week here. So one thing I wanted to bring up was during the course of some BlueStore testing we were doing, I started getting concerned about RBD client-side bottlenecks, and it turns out that I had inadvertently forgotten to disable RBD cache on this particular test I was running, so I was right to suspect client-side bottlenecks. Unfortunately, it's actually a little worse than I remembered it being from the last time I looked at this. So the deal is that when you're on NVMe OSDs or just really fast OSDs in general, it's looking like FIO using the librd backend is limited to about 14 or 15K IOPS for one client, and it's using about 300% CPU to do it. Now that we've got our handy dandy wall clock profiler that we can look at this, and dig in under the covers now with, as it turns out, we're seeing lots and lots of lock contention. So Jason, I think, suspected this already, but it's a pretty big bottleneck for single client RBD clients. When you get rid of RBD cache, when you take it out of the loop, you can actually get closer to about 36K IOPS per client with enough concurrency. So it's something like a 2.5x improvement. It was using a little bit more CPU to do that, and there's still some bottlenecks if you look at the trace, but a lot of the lock contention goes away, and we start seeing some other things. There's actually still some lock contention, but it's in other places, and we start seeing some other things like placement and async messenger starting to consume a lot more of that CPU time. So I guess the good news is that there is sort of a workaround by just totally disabling RBD cache. The bad news is that you have to disable RBD cache to work around this. So yeah, I just wanted to let people know this is out there, and it's probably something that sooner or later we need to look at. But for now, 36K apps from a single client with RBD cache disabled is probably good enough for the moment. For most users. So that's that. On the BlueStore, go ahead.
Sorry, just a quick question around that. Slightly related. Have you ever done sort of testing with an RBD with like a file system on top?
Yes, we have done a fair amount of that in the past, but running those tests is more complicated than running the FIO RBD tests. So to be honest with you, I don't do it very often anymore.
I've just been sort of looking into something the last couple of weeks. Because obviously, like on XFS, the journal is effectively like pretty small. It's like something like 128 meg or something. I just wondered if do you start getting PG contention if XFS is quite good at parallel workloads, but if you're getting a large parallel amount of workloads going on the main part of the file system, does that journal, since it's only going to be sitting over a handful of objects, start to become a bottleneck because they're all waiting on the same PG?
That's a very good observation, and I think that there's a good chance that you could. Right now, already with small sequential writes, at least in BlueStore, and I suspect it's the same in FileStore, I wouldn't see why not, but in BlueStore specifically, if you look at a wall clock trace of doing small sequential I/O, you see a lot of PG contention. And even with random writes, sometimes we're seeing PG contention. So I think your observation is spot on. There's a very good chance that we will see that.
Yeah, I've been trying to sort of make a second RBD with like something like 64K, made of 64K objects, and then putting the external journal on that to sort of try and see if that makes any difference. But so far, I haven't really managed to get any sort of meaningful results. But there might be other sort of things I'm hitting. But it was just something I was thinking, that maybe the journal needs to be on something where it's got more granular objects, so it doesn't get caught so much on the same PG.
Yeah. The maybe the counterpoint to that is, in a lot of situations, folks will have lots of volumes, right? Not just one volume talking to lots of OSDs. So in that situation, maybe it doesn't matter as much because you have journals spread across lots of OSDs and lots of journals. But if you've got only a couple of file systems being utilized heavily at any given time, it's still you're maybe only hitting a couple of PGs for the journals. And
that's what I think, because I've sort of, one of the things we use is NFS, like a big 15, 20 terabyte volume via NFS to ESX. And so effectively you're just getting like thousands and thousands of sync writes, but it seems to be you hit a limit where bumping up more things doesn't seem to get any more performance, even though the back end is capable of it. And I was starting to think whether it was the journal which was sort of starting to wait on PGs, which was stopping any more IO occurring.
Sure. Yeah, no, it's quite possible, I would say. I mean, you could, if you happen to have the opportunity to run the test, you could try using the wall clock profiler that we've got now. And someone's scrolling through it on the screen here, I see, actually. But yeah, you could just try running that during the test and see if you see the PG lock showing up.
Okay. Yeah. Okay.
Yeah, that would be really interesting to see, because we kind of already know that the PG lock is contended in various situations, so we need to figure out what to do about it. Yeah, it'd be good to see if that actually is true.
Okay.
Cool. Yeah, that's good. So let's see what else. Yeah, there's this sync write stuff in BlueStore we sort of already talked about. That might actually help a little bit. We'll see. There's this KV sync thread split PR. And Igor, are you here? I think Igor's here, but he's still muted. So Igor mentioned to me about a week ago that he was seeing a really, really big performance boost with this. And he actually ran through a wall clock profile on it that he had shared with me. That so right now, when we do like 4K writes on NVMe or some kind of fast storage with BlueStore, we see the KV sync thread is really busy. Both in submit transaction and then doing other stuff too. And this KV sync thread split PR looks like it pretty dramatically changes that kind of trace where we're spending times and things in the threads. So it looks really interesting, at least based on the profile that Igor sent me. So I'm hoping I'll get a chance to look at it again. I think last time I wanted to, it was it needed to be rebased, and maybe it does again by now. I don't know, but that looks hopeful. I think that the work that's been done on that by various folks is going to pay off. So yeah, that's very good. I think the only other thing I'll mention here is Sage mentioned that we've got folks that are interested in seeing how 3x replication on file store compares to doing erasure coding with BlueStore. And kind of one of the motivations for that is that we've seen some pretty positive results with erasure coding in general on BlueStore, quite a bit better performance than we did with FileStore. So it might actually be worthwhile for people now to take maybe a slight performance hit if we can justify that on BlueStore by using erasure coding and save a lot of space, especially now that we can target erasure coding with RBD. So we'll probably be looking at that a little bit closer in the coming weeks here, and then also maybe run it through some wall clock profiles and see if there's anything that we can speed up. So yeah, that hopefully will be coming. So that's all I have.
What EC policy for the erasure coding? What was the EC policy they were looking at? What, 2.1 or 3.2 or?
The test that we did a couple months ago, I think we did 2.1, we did 4.2, and we may have done another one. I don't remember off the top of my head. It might have been 6.3. But basically across the board versus FileStore, we were seeing pretty dramatic performance improvements with BlueStore versus FileStore. In some cases, we actually saw that something like an EC4.2 pool was faster than 3x replication for large writes. And that you'd kind of expect that if it was working well, you would hope that that's what the case would be because you'd be writing out less data. The big question will be, can we get it to be close to as fast or even sort of close to as fast for small writes? And I think that's where we're going to see problems.
Large writes being more than 1 meg or more than 4 meg?
In that case, it was 4 megs. They're 4 meg writes.
Yeah, real interested in that.
Yeah. So for BlueStore, we were actually seeing that 4 megabyte writes were, I think, if I recall off the top of my head, they were somewhere between 2x and 3x replication. We were seeing speed somewhere between those two. But again, for small writes, at least at that point, I think we were still, quite a bit slower than replication for small writes. But we hadn't really dug into it a whole lot. It was still faster than FileStore was, but that's something that might still be the case, and there might not be a whole lot about it that we can do for Luminous. So we'll just have to see. But yeah, for large writes, it was actually looking pretty good. So we'll probably dig into it a little bit more in the coming weeks here. But that's kind of what I remember of the testing that we did a couple months ago.
Do you know if there's going to be any effort to allow it to do partial reads from the stride instead of having to read every single shard?
I thought that we had some kind of experimental option to be able to, at the very least, do exactly that. Like if you've got something that's slow, being able to read from everything and then like recompute it or something and then return it.
I don't know. From what I remember, I think it was Sam confirmed this a couple of months ago, was that for a read, it does have to read from every single shard. So if you have to read like the 4 meg across all of the OSDs and then pick out the 4K or whatever from it.
Okay.
What I found with spinning disks is the average latency really starts to go out for that because it has to wait for potentially 6 disks or whatever to return.
Sure. That's I remember talking about this with somebody, but now I don't remember exactly what it was said. So we'll have to look into it. I know this was discussed, and for some reason I thought something merged, but maybe not. Anyway, sorry, Nick. I'm striking out 2 for 2, I guess. All right, so that's all I've got. Anyone have any last minute things that they want to bring up or talk about before we wrap up for this week? All right. Well, have a good week, everyone, and we'll reconvene again next week. And for the folks from Alibaba, I will try to get something set up with Greg and Josh, and we'll go from there.
Thank you, Mike.
All right. Have a good week,
Thanks, Mark.
everyone.
Bye.